Hey folks. So in this section, we are going to be learning how to graph and numerically summarize data when we have one categorical variable and one numerical variable. The files that you're going to need when you follow along with this video are the beer ABV Excel file and the one cat and one num variable beer ABV R code, both of which can be found on Canvas. All right, so to summarize data that has one categorical variable and one numerical variable, um, we are separating our data by categories, and then we're analyzing that numerical variable. So we're doing the same things we did before when we had one numerical variable. We just have to do it for every single category. So we're going to do shape, center, and spread, which we did before. So shape, center, and spread. But we add a fourth thing that we have to do, and we compare what we see between the categories. So shape, center, spread, and compare. So for shape, we graph the data or visualize the data, and we do so by category. And then we describe what we see in each of the graphs, and all of our graphs for each category must be on the same axis. You can use stacked histograms or stacked box and whisker plots here. I don't use stacked histograms because they're particularly difficult to read. Then for center, we use either the mean or the median by category, and you do not mix and match here. If you choose to do the mean for one of the categories, you do the mean for all categories. If you choose to do the median for one category, you do it for all. I typically err on the side of if there are any outliers, I would use the median for all of them. There's no necessarily right or wrong here. And then for spread, we use either standard deviation variance or interquartile range. Again, we don't mix and match. If you have used the mean for all of your categories, you should be using standard deviation or variance. If you have used the median, you should use interquartile range. So if you use means, you use standard deviations or variance. If you use medians, you use interquartile range. So same rules as before, you guys, with the one variable data. So no surprises here. So we have an example that we're going to work through. It'll take us quite a while to work through it. We have a beer database. I have reduced this database to just 3 American beers. And we're going to compare the amount of alcohol by volume for all of these. So let's take a quick look at this data. Actually, we'll just look at the data in R. So I'm going to go ahead and import it into R. So in RStudio, I have the file one cat and one num variable beers ABV file open. And so I'm just going to go ahead and import this beer data real quick. So I'm going to go to File, Import. Remember, you can go do it on the right side if you want. It is an Excel file. So I need to find this file in my computer. Beers. There it is, Beers ABV. And I'm going to open that file and we're going to take a quick look at it. You can copy this code preview into your file if you want to. I'm going to go ahead and do that. Control C. I hope the keyboard works. If not, it's not going to help me. And then we'll come back and look at the data in just a minute. Control V. Oh, look at that. It does work. I'm using a different keyboard, so that's very helpful to me. Now let's take a quick look at this data. So variable 1 is ABV, it's alcohol by volume. And then variable 2 is beer style. And if I scroll down, I have American IPAs. And then there are a lot of those. I have American Pale Ales, otherwise known as APAs. And then I have American Stouts. And you guys, there are about 150 some odd pieces of data here, 153 to be specific. And we have beer style and alcohol by volume. We're going to come back to that in just a minute after we do these questions in the notes. So which variables is our explanatory variable? So the data was put in with ABV first in this file and then beer type, but that is not the right order in terms of which one is explanatory and response. We are interested in the alcohol by volume by beer type. So beer type or beer style is our explanatory variable. So beer style is our explanatory variable, and it is qualitative, also considered categorical. Qualitive, categorical. And then which variable is the response variable? That's our alcohol by volume, so ABV. And that is numerical. And remember, that can also be quantitative. So when you have three categories like this, so we have three different beer styles, there are three of them. And then we have a numerical response variable. What we want to do is break up our response variable by each of our categories and do a graph for each one of the categories. We do this with a stacked box and whisker plot. And you guys can actually see this plot on the page here. I've made it for you. So our R code for this graph is going to be box plot, just like it would be if we had one variable, but now we have to categorize or break these up. And you always put your response variable or your numerical variable first. So we're going to have our data frame name, which is, I think it's beers, ABV, and then $sign, we want ABV, and then you use a tilde. So that's the squiggle that's in the top left of your keyboard. And then we do beers ABV again for our data frame again, but this time we want the other variable, which is beer style. And there's a space in there. I'm not going to worry about getting it on here perfectly. So the first variable is always the numerical variable. And the second variable is then your categorical. Categorical. I think I spelled that right. And then this thing in the middle is called a tilde. Most students just call it squiggle. If you took Spanish, you know it's a tilde. Or if you speak Spanish, you know it's a tilde. But if you didn't, you might just call it a squiggle, and that's okay. So we can take a quick look at our graph. So what we can see is that American Pale Ale has a much lower median than American Stout and American IPA. American Stout is a little bit skewed right. American Pale Ale is a little bit skewed left. And American IPA actually looks relatively symmetric, but there are a bunch of outliers in these graphs. So what we're going to want to do is so we've visualized the graph, and we'll put this in our code in a minute. We've visualized it, and we'll talk about the shapes of each graph. We need to calculate the center. Some people might use median here, some people might use mean here. Because we don't have a bunch of outliers with the first two graphs, because they're skewed and the last graph has outliers, I would recommend using median here. And if we use median, then we use interquartile range for the spread. And we would do it for all three of the categories. And so that's what we're going to be doing on the next page in this table. So we have American Stout, we have American APA, and we have American IPA. And then we are going to do the median just because I said so. Median for each of these. And then because we use the median, we will use the interquartile range. And then we can see the shape of each of these. If you wanted to, you could do a histogram for each one. Let's go and work on some of the code now. So we want to create the side-by-side stacked box plot. And for this graph, we put in our data frame name, $sign, and the numerical variable. And so we're going to do this in our code here. So I'm going to do box plot. And then the data frame name is beers, ABV. It'll pop up. Remember, you just have to wait for it. And then $sign, my numerical variable is ABV. So that's the one I want to select. And then you have to do the tilde. The tilde is in the top left corner of your keyboard. Then we want to do beers ABV again. It'll pop up again, and then $sign, and then we want to use our categorical variable. You could, by the way, have a data frame that has 20 variables in it. You just have to make sure you select the right ones. Okay, so we have box plot of data frame, $sign, numerical variable, tilde, data frame, $sign, categorical variable. And then I'm going to give myself a little bit more room for this graph, and I'm going to run it so you can see what the base graph looks like. So the base graph is a completely acceptable graph in terms of it being vertical, and it tries to give you X and Y labels. They're not very good. It does not give you a title. And notice it can't write all of the words for the 3 categories on this axis. So I have to make some edits to this graph. And some of the detailed commands that you can use are to rotate the graph. So beside equals true gives you side-by-side graphs. Horizontal equals true rotates the graphs 90 degrees. Par-mar affects the margins. You guys have seen that already in a homework. And then we can still use x-axis and color. I'm showing you a different way to handle color now. If you don't want to pick the 3 colors you want your graphs to be, you can use color equals rainbow feature and then tell it how many colors you want. So call equals rainbow, and I think that's supposed to be rainbow with no space there, 3. And so it will pick 3 colors for you and make each graph one of those colors. You guys already have the code here that you need. So it's the box plot of the data frame $sign ABV, tilde, data frame $sign beer style. And then I've given you a title, an X label. I actually just got rid of it. For it actually, it's the Y label, but because we're going to rotate it, you'll see which one it is in a minute. And then X label becomes our alcohol by volume because we're going to rotate this graph. You can use beside equals true. We don't really have to do that here because we've got the categories broken up in our data properly. Last equals 2 rotates the beer data, what type of beer it is. X-axis reduces the size of my data. And then I put par-mar in this one. You can put par-mar in a box plot, and that edits my margins. And then I do want this graph to be horizontal. So horizontal equals capital T, or I think you can do capital T RUE. And then for the color, I did rainbow 3 because I have 3 graphs, and I'm going to run that, but I need to give myself a little more room when I do this. And we now end up with the graph that's in the notes. So notice that my X lab is ABV for alcohol by volume because I rotated the graph. And by the way, I regularly mix up which one is my X and Y when I graph these things and have to switch them when I start rotating graphs. And then notice that I didn't actually put beer type here. I think that's it's pretty reasonable that anybody reading this would know that this is a beer type, especially since the title is alcohol by volume. So it's clearly some sort of alcohol. All right, so now we can calculate the basic statistics that we need. And there are a couple of different ways to do this. We can do the aggregate feature where you aggregate your data using the data frame $ numerical variable, comma, and then you list your data frame $ categorical variable, comma, and then whatever function you want. And you'll see that I've done this down below for you. I've given you the aggregate result. So let's do the median first. So you can just see that one. So I'm only going to run the median line of code. And what you get is it says group 1 is American IPA, American APA, or American Stout. And then X is the median here. It's 0.0680, 0.0565, 0.0615. And then we can do that for the interquartile range. And then we can also do it for the mean if we want to. And notice, well, except it's not running those. Give me a second. Let me do IQR. It's running median again. Why is it running median again? There we go. There's the IQR. And notice that these numbers changed, but the category stayed the same. And then I want to do the mean line, and those means would be close to the medians. And then I could do standard deviation, but I could also do summary, which gives me all 5 numbers. And when it did that, well, darn, it's not doing standard deviation. Oh, that's because I'm hitting the wrong button. There we go. So standard deviation is there. And then if I want to do summary, I need to hit run this time. You guys, it gives me all of these things, the minimum, the first quartile, the median, the mean, the third quartile, and the maximum, all in one set of output. But there are these things called mini programs that are built into R that do some of the things that I just showed you how to do with the aggregate function with either fewer lines of code or they put our output out nicer. And to use these, you have to first load one of your books that you get out of the library. The book that we're going to the library to get here is called the Tidyverse. And real quick, I just want to show you guys, not everybody is going to be able to have the Tidyverse. To get the Tidyverse, you go to Packages, and you can search for Tidyverse, Tidy. And if you have Tidyverse, you're going to want to check that box to install and load the Tidyverse function. And all kinds of stuff's going to happen down here in the bottom left, and just ignore it if some of it's red. But some of you won't have the Tidyverse function on the right over here. When that happens, you need to go up to Tools, and then you need to go to Install Packages, and you just search for Tidyverse, Tidy. And when you start typing tidy and scroll, you can scroll down until you find the Tidyverse. If you type tidyv, then Tidyverse is one of the options, and you would hit install. And then you can click the Tidyverse over here on the right if it doesn't automatically put it over there. And I'm not going to do that because I already have it. So now I'm going to go back to my plots function. By the way, that packages function was just beside the plots for those of you that missed it. And then if you need to install it, you can hit rewind, but it's at the tools button and you install packages. So if we do the library tidyverse, then we can do something called grouping the data. So we do group by data frame, comma, categorical variable, and then we have to do this thing called piping. We pipe that categorical variable to whatever function we want to use of our numerical variable. So the next line of code is going to be summarize, and then you name it something, is equal to the function of the numerical variable, and then you will have to view your output. This weird thing, the percent arrow percent, is called a pipe. And what we're doing is piping from one function to another or from one variable to another. And you can either type percent arrow percent, or you can use Control Shift M, as in Mary. If you are on an Apple, you would use Command Shift M, as in Mary. And so with the tidyverse, I've given you guys this code. So for us, we have to run the library tidyverse. That's one line of code. And then we group by Beer's ABV, which is our numerical variable, comma, beer style, which is our categorical variable. And notice, oh, sorry, beer's ABV is our data frame, comma, beer style is our categorical variable, and then we pipe that to whatever we want to do with our numerical variable. I want to summarize the numerical variable using the mean of ABV, the median of ABV, the standard deviation, and the interquartile range. And then I want to view everything I just did. So you guys, I literally type view and then I copy these two entire lines and just paste them inside the view parentheses. So I'm going to run these 3 lines of code. These look like 5 lines of code, but they're really only 3 lines. But I do have to highlight all of them to run them all together. And I need to give myself a little bit of room. So I highlighted them all and I'm going to run them. And I get output here in the bottom. But because of the way we did this in the tidyverse, tidyverse gives me a very nice table output. And this table you can put into a document, you can cut and paste it. And so I would just cut and paste this using the snipping tool. And now what I have is my beer style, my means for all of them, the medians for all of them, the standard deviations for all of them, and the interquartile range for all of them, all in one place. And so now we can fill those in the notes. So for us, the median was 0.0615 for stout, 0.0615, and I'm just going to double check that because I want to make sure I didn't screw them up. So stout is the median's 0.0615. The APA is 0.0565 and IPA is 0.0680. And then I'm also going to pull the interquartile ranges and write them down in the notes. So APA, the median is 0.0565. The median for the IPA is 0.0680. The interquartile range for stout is 0.0105. And the interquartile range for APA is 0.0130. And then the interquartile range is for IPA is 0.0070. And those just all came out of my output. Again, you could get all of these from the aggregate output, or you could get them from the tidyverse output we just did. The stout, the graph for the stout, which is the top graph, is a little bit skewed right with no outliers. So skewed right. Whoops. No outliers. The APA is the middle graph. It's a little bit skewed left with no outliers, so it's skewed left with no outliers. And then the last one is the IPA. It's the bottom graph in red. It looks to be relatively symmetric, but it has outliers on both ends, and it's got a lot of them. So I'm going to call it symmetric. I don't know if it's mounded or not, with lots of outliers on both ends. And then the last thing we're going to do is a comparison. That comparison, typically what I write is just something about the center and the spread. So I'm going to say IPA has more alcohol than the others and slightly less variability when looking at the middle 50%. So IPA has more alcohol by volume, ABV, than the other two beers, but has slightly less variability when looking at IQRs. So I didn't look at standard deviations, I just look at the interquartile ranges. All right, so there's a whole lot of programming that you can do to get these outputs, you guys, but you don't have to do all of the things that I showed you. You could do aggregate this way. It won't give you a nice table, but you can always take that data and make a table in Word or Excel. You can use the tidyverse and do it the way I just showed you here, or there's a third way called dplyr, and this is another one of those functions that you have to run the tidyverse first. So if you have not run the tidyverse, you have to run it to get the dplyr function. And then you can follow my instructions here if you want to run the do the dplyr method. So I'll show you what it looks like real quick here. Let me run that. There we go. So it gives me the same table we just got. So that table shows up with dplyr and with tidyverse. All right, that's it for one.